Okay, hello and welcome again. Today we will be revising the chapter light. What I will do is, in this class I have just got some numericals and some important questions for you, and maybe in the next class we will start with revising some of the important concepts of the light chapter. So let's first understand how to solve some of the numericals here. So all of you have to solve all these questions along with me. Okay, so let's move on to the first question. The first question is that the radius of curvature is 20 centimeter. What is the focal length? Okay, so as I told you that anytime you're given any numerical, you have to write down the given data. So here what is given to you? You are given the radius of curvature, which is 20 centimeter. Right. So let's say, what is radius of curvature? If you draw a concave mirror, this is the principal axis, this is the pole here, this is the focal length, and this is the center of curvature. Now you know that the center of curvature is actually the geometric center. If this is center of curvature, that means this distance is your radius of curvature. So now here is the focus, and you know that the focal length is half of the center of curvature, right? So focal length is half of the radius of curvature. So if you have to calculate the focal length, okay, you can write 20, this is a formula, you can divide 20 by 2, which is going to be 10 centimeter. So that gives you your focal length. Is it clear? This point, I'm sure each one of you are clear. Your focal length is half of your radius of curvature. That's why you have divided 20 upon 2. Now let's look at the second question here. An object is placed at a distance of 50 centimeter from a convex mirror. State two characteristics of the image which is formed. So here what kind of a first, and whenever you come across any numerical, you have to clearly write what type of a mirror or a lens is this. So in this case it is clearly said that it is a convex mirror. So I'm drawing a convex mirror here. This is the principal axis. This point is known as the pole of the mirror. And what is given here is, we know that our object distance is 50 centimeter. So let's say this is 50 centimeter. Here I place my object. Now he's asking what are the two characteristics of the image. Now if you recall the ray diagrams that we had drawn, anywhere you place your object in front of the concave mirror, let's say you place it here. So what is going to be the nature of the image formed? How is the ray going to look like? Okay, the first ray is going to travel like this, and then it is going to be reflected like this, and so that it just appears to pass through this focus. Correct? The second ray is going to go like this. Is going to go like this in such a way that it passes through the center of curvature. So where these two lines will actually appear to meet here. Okay. So what do we see? We see that the image is always erect in nature. So what is the characteristics here? He's not asking you the distance of the image where it is formed. No, he's just asking you the characteristics of the image form. So first is, the image is going to be erect in nature. Whenever it is erect, you know that it has to be virtual in nature. And next, the second one is, it will be diminished in nature. It will be diminished in nature. So erect, virtual, as well as diminished in nature. So these are the characteristics of the image which is formed by the convex mirrors. Now the next question is, an object which is 50 centimeter tall is placed on the principal axis of a convex lens. Its 20 centimeter tall image is formed on the screen placed at a distance of 10 centimeter from the lens. Calculate the focal length of the lens. So here, as I told you, clearly you have to write the given data. So in this case, and also you have to write what kind of lens or a mirror is this. So here it is a convex lens. So what is a convex lens? Let us draw convex lens. This is the kind of convex lens. This is the principal axis here. In the center here we have this O is the optical center. Fine. So what is given here? You have the 50 centimeter is nothing but the height of the object. So This is 50 centimeter is the height of the object. Now look what else is given. It's 20 centimeter tall image, which means it is the height of the image, which is 20 centimeter. There, see, whenever you write any quantities, like here you have written some physical quantities given to you. What is that? Height of object and height of image. Whenever you write any numbers, any value, just ask yourself, is it going to be positive or is it going to be negative? So first of all, we have the height of the object. So it is 50 centimeters. So which means the object generally we place like this, on the left hand side. So, and what is the height? Height is in the positive, in the upward direction. So it has to be positive. So it is positive 50, which is okay. Now look at the height of the image. In this case, the value is given as 20 centimeter. But now ask yourself, what is going to be the value? Is it going to be positive or is it going to be negative? Now, then you have to recall the ray diagram of the convex lens. In the ray diagram of convex lens, if you remember, almost every position, wherever we place our object, what kind of an image do we get? We always get an inverted image. So in a convex lens, we will get inverted image, which means what should be the height of this image? It has to be negative 20 and not positive 20. It has to be negative 20. So the question is not going to tell you whether it is positive or negative. The question, it will only tell you the value of the quantity, but you have to decide about the sign, whether it is positive or negative. So we have h is equal to 50 centimeter and h dash is equal to 20 centimeter. We also have one more thing given over here. Here's, look, it is formed on the screen, placed at a distance of 10 centimeter. So which means our V is also given, which is 10 centimeters. Now where is the image formed? The image is generally formed on the right hand side of the optical center, which means it is positive. So first write down whether any quantity which is given to us is positive or negative. Okay. Now what do you have to calculate? You have to calculate the focal length. Now for calculating the focal length, the formula is 1 upon f is equal to 1 upon v minus 1 upon u. So you know v, but you do not know your u. So you cannot calculate your f. So there are two more things which are given to you. Look at this. You are given the height of the object and height of the image. What can you calculate using these two? Now recall the formula for the magnification. Magnification is equal to h dash upon h. So when you calculate this, you will be getting minus 20 upon 50, which you will get minus 2 upon 5. So this is the magnification. Now with this magnification, if you know your v, you can also calculate your u. Okay. So how will you do it? You know your magnification and you also know that the formula for magnification in case of lens is V upon U. Okay, which is minus 2.5. So you can actually equate like this. V upon U is equal to minus 2 upon 5. So you already know V. Okay, what is V? V is 10 upon U. You do not know, minus 2 upon 5. So you will be getting U is equal to minus, it will be 50 upon 2, which will be 25 centimeters. So this is your U. So now in this case, I have not given you focal length and I have not given you U. So two quantities you do not have. But because there is no focal length, I have given you H and H dash. So using that, you can calculate your U, which is equal to minus 25 centimeters. Now you know your U, you also know your V. Can you calculate your focal length? Somebody has written focal length as 7.12, which is absolutely correct. Harshita, okay, 7.12, it is fine. So I hope you can solve it now. I've given you U and V both. Okay. So let's quickly move on to the next question. At what distance should an object be placed from a convex lens, focal length 18 centimeter, to obtain an image of 24 centimeter from it on the other side? Okay. So here focal length is given. So first let us write what is already given to you. You are given focal length, which is equal to 18 centimeter. First of all, you have to see which kind of lens or mirror is this. So this is again a convex lens. So you have to draw a convex lens like this and place a principal axis here. So you are given 18 centimeter. Now this focal length, whenever any numerical value is given to you, please write positive or negative. Okay, please write positive or negative. So this is going to be positive because focal length is going to be on the positive side here. You are also given your V, which is 24 centimeter, which is again is going to be positive because in this case of a convex lens, the image is always formed on the other side. Okay, then you have M, which is equal magnification you have to calculate. Okay, what will be the magnification? So is your U given? No, your U is not given. So your U you have to calculate. Okay, now you know your V, you know your F, you can calculate your U. What is the formula in case of lenses? In case of lenses, the formula is 1 upon F is equal to 1 upon V minus 1 upon U. Just calculate and let me know. So 1 upon V minus 1 upon U. So you have 1 upon F, which is 18, is equal to 1 upon V, which is 24. Okay, 24 minus 1 upon U. So you will write 1 upon U like that. Just solve it. I'm also solving it parallelly along with you only. So you will be getting 1 upon U is equal to 1 upon 24 minus 1 upon 18. If you solve it, you will get 72, and here you will get 3 minus 4, which will be 1 minus 1. Minus 1 upon 72. So that means your U will be equal to minus 72 centimeters. Okay. Then you have to calculate your magnification. What is going to be your magnification? It will be V upon U because it is lens. Now when you do V upon U, what is your V here? Your V is 24 upon what is your U? It is 72, but a minus sign will come here. So you will be getting 1 upon 3. So that is your magnification. So this is how you have to calculate magnification. Okay. Let's see this one. An object is 1 centimeter high produces a real image of 1.5 centimeter. You have to just read the lines very carefully and jot down what is the given data. So here what is given to you? An object is 1 centimeter high, which means my object height is 1 centimeter. This is my height given, the height of the object, correct? It produces a real image of 1.5 centimeter high. So what is 1.5? 1.5 is the height of the image. Okay. Now, what else is given? When placed at a distance of 15 centimeter from the concave mirror. So here itself, please draw a concave mirror so that you know which is positive, which is negative. Okay. So it is, what is given? U is given as 15 centimeter, but it has to be minus 15 centimeter. Okay. Okay. So it is minus 15 centimeter. And you are supposed to calculate your position of the image. So you are supposed to calculate your V. Okay. So now H is given, H dash is given, U is given, V is given. You have U, you do not have V. You also do not have your focal length. So I told you, whenever there is no focal length, there should be something which can help you in calculating the focal length. So look at these two. You are already given H and H dash. Similar, this question is very similar to what we actually did. Okay. It is actually not a lens, it is a mirror. Okay. So concave mirror. Let me just draw mirror. Fine. So now, so using this H and H dash, you can calculate first your magnification. So what is the formula for magnification in case of concave mirror? First you will be writing H dash upon H. Okay. Now here again one more catch you have. Tell me what is going to be the image height. The image height should be negative and not positive, because suppose if you keep your object here, you see that what kind of image is formed? Generally the kind of image which is formed in the case of concave mirror is inverted. So you have to put it as minus 1.5 centimeter and not plus 1.5. So minus 1.5. So let's say if I put minus 1.5 divided by 1, you will get minus 1.5 as magnification. Now if you use this magnification, and calculate your V, look at the magnification formula in case of mirrors. It will be minus V by U. You please do not forget this minus sign. So what you have to do is minus, what is your V? You do not know, upon, what is your U? Your U is minus 15 is equal to minus 1.5. Okay, so this minus minus gets cancelled. So if you calculate, you will get V is equal to 15 into 15 is 225. So you will get 22.5 centimeter, but it will be minus. There's a way to go about answering these questions. Any numerical value is given to you, ask yourself, is it going to be positive? Is it going to be negative? Fine. Simply, if you just jot down all the values and start doing the numericals, it will be wrong. You have to ask yourself, am I writing height? Height is given to me, but is this positive or negative? Fine. Okay, next question. What is the power of the lens if the focal length is 20 centimeter? I want you to calculate this for me. Okay, very easy, simple and a short numerical. What is the power of the lens if the focal length is 20 centimeter? Let me know how many of you are able to calculate. Well, I'll give you the formula for power. It is 1 by F, but remember the F is will always be in meters. So if it is in centimeters, you are supposed to convert that into meters and let me know. Be 20 centimeters into meters, it will be 1 upon 0.20. Okay, so your power is going to be 1 upon 0.20. So if you solve this, you will get 5 diopters. Okay, so I hope that was easy. Look at the next second question now. Which of them will have greater power, focal length of 5 centimeter or focal length of 50 centimeters? So I've given you two focal lengths. So this was the first part. This is the second part. One is 5 centimeter, one is 50 centimeter. Which of them will have greater power? So you know, if the focal length is less, the power is going to be more. So it is going to be 5 centimeters. Okay. Okay, so all of you, I believe, are following till now whatever we have done. Next question, define one diopter. So first, whenever any simple definition is asked to you, you have to write the formula. So formula is power is equal to 1 upon F. So if the power is 1 diopter, then the focal length has to be, which means has to be 1 meter. So now how will you define this? 1 diopter, it is the power of that spherical lens where the focal length is 1 meter. Very, very important. Okay, you need to know what is the definition of 1 diopter. Look at this next one. We have an object which is placed at 60 centimeter from the concave lens. Okay, so we are again going to draw the diagram. All of you should draw it in your copies so that it will be clear to you. So let's just draw the concave lens here. Okay, so this is your optical center. Fine. Now object is placed at 60 centimeter from the concave lens. So what is the object distance? It is 60 centimeter. So it will be equal to minus 60. Correct? Minus 60 centimeter. Focal length is given as 30 centimeter. So I have written two things here. First is 60, so I put a negative sign here. What about the focal length of a concave lens? Let me know whether it is going to be positive or negative. I'm waiting for your answers. The focal length is given as 30. So should I mark it positive or negative? So how do you draw the diagram? For this, you need to know how to draw the diagram. The first ray comes like this here. Okay. It gets reflected like this, but it appears to pass through focus. The second ray goes like this. So where do they meet? They meet somewhere here. So it is negative. Yes. So I will put a negative sign over here. So now I know my U, I know my F. What is the distance of the image from the lens? So he's asking you V. So can you calculate V? Just put down the formula. We have lens. So the lens formula is 1 by F is equal to 1 by V minus 1 by U. So your F is minus 30 is equal to 1 by V minus, and minus becomes plus 1 upon 60. Okay. So it is going to be minus 1 by 30 minus 1 by 60 is equal to minus V. So let me know what is your V. What do you get as V? I hope this is pretty simple and you can calculate. Let me know how many of you are able to calculate V. Okay, Prashant says it is minus 20 centimeter. Anybody else? Write down your answers quickly. Okay. Saksham says it is also minus 20. Fine. Akshit minus 20. Fine. So I'm not calculating that for you. I am assuming that it is V is equal to minus 20 centimeter. So it is very logical because you will be getting the image on the left hand side only. So it is minus 20. Now look at this. He's asking the nature of the image formed. How is the nature of the image? Okay, now suppose, now you have to calculate your magnification. Fine. So how do you calculate your magnification? Your magnification in case of concave lens is V upon U. So just divide and let me know what is the calculation. It is also too simple, and then you have to comment on whether it is inverted or an erect. It has to be virtual and erect. Okay. What is the magnification? Magnification is 3. Can't be 3 because in case of concave, see, whatever you are getting your answers, it has to be logical also, right? It can't be 3. How is 3 means your image is more than your size of the object. It has to be 1 upon 3. Very good. In the diagram, the image is erect and the image is small. So suppose if you substitute in this, you are getting minus 20 upon minus 60. Okay, so you will get 1 upon 3. So your magnification will be 1 upon 3. Magnification will be 1 upon 3, which is quite logical. So first we have to draw the glass slab, and you have to show that this is an incident light ray. Also you have to mark that this is an air medium and this medium is glass, and this again outside is air. So you have to, so the light is coming, so I mark here as this is the normal here. So this is my incident ray. Then comes my refracted ray because it is going to bend. Then again I draw normal, and then it is going to come out like this. So this is the emergent ray which is going to come out. But now if you extend this ray like this, then this will be your original ray which would have come out. Okay, so what is the lateral displacement here? This is the lateral displacement. This one, this is the lateral displacement here. Okay, so also along with this you have to mark all the angles here. Okay, suppose this is your incident, the angle of incidence. Okay, then this will be your angle of refraction. This will be your second angle of refraction, and this will be your emergent angle. So you have to mark all the angles here. So this diagram is very important for you to learn. Also, what is lateral displacement? It is the difference between the emergent ray as well as the original ray which would have come out had the glass not been there. Okay. Okay, next one is a person uses a concave mirror for shaving. Where should he position his face in front of the mirror? Suppose somebody is shaving, where should he place the mirror? He should place the mirror very, very close to his body. Tell me why? Because if you remember the last diagram, when your object is placed between pole and the focus, only at that position you will be getting an image which is much larger in size, and it is the only image which you will get, which you will find it erect. So here you are supposed to draw the last diagram in case of concave mirror. This is your focus, this is your C. Here you have to place it here so that you will be getting a very enlarged image. So you need to draw this diagram and learn it. Okay. Okay, a ray of light is incident on a concave mirror along the principal axis. What will be the angle of reflection? There is a ray which is incident on, okay, so suppose this is a concave mirror. This is it. So there is a light ray which is coming like this. If it is incident here on the concave mirror, what is going to be the angle of reflection? If it comes like this, so let's say if I draw a normal here, so this will be my angle of incidence. It is going to come and pass through the focus here. Okay, so this is going to be by angle of reflection. But the angle of incidence is equal to angle of reflection. I have some more questions here. but let's stop at this point. Okay. So whatever questions we have already done in the videos, as well as the revision classes and your exercise questions, only those questions will be asked.